All right, hello. We are going to work with molarity in this video. So here you see in the very beginning, we have the formula for molarity. So once again, that big fancy M, and it is going to be the ratio of moles to liters. So the formula is mole over liters. So we're going to do two types of molarity problems. The first one is going to be a pretty straightforward one. You have 500 mLs of water. To it, you will add 3.075 moles of a substance. What is the molarity? So once again, this is going to be 3.75 moles of a substance. What is the molarity? So let's take some notes. We know that we need some type of mole for this problem, and we need some type of liter or volume. Okay, so in our problem, we know the first thing we're looking for is mole for the top, and it says that we are going to add 3.75 moles of a substance. So there we'll just put 3.75 moles. We don't know what it is. And at this point in this type of problem, it doesn't matter. But here we have our volume is what needs to go on the bottom. But we've only got 500 mLs. So what would we do for this particular problem? You are absolutely correct. We would go ahead and convert this 500 mLs into liters. So I'm going to go ahead today and show you a small example of dimensional analysis. So in dimensional analysis, on the far left, we put what we are wanting. So we want liters out of this volume. Whatever unit here is on the left of our problem is going to go here. And what do we have? Do we have any liters provided to us in the problem? I'm sure if you could answer me, you tell me, Erica, there are no liters. So now we're going to use what is called a conversion factor. So we need to change milliliters to liters. So that conversion factor, we know for every 1 liter, we're going to have 1,000 milliliters. And were we given any milliliters in the problem? I certainly think so. Whatever unit is on the bottom here is going to go directly across. Go reference that problem again, and you'll see that right there we have 500 mLs. So we're going to fill that in. And he isn't married to any other numbers. It doesn't say 500 mLs with something in it already, so we can put him over 1. Crossing out our like terms, ml here and ml here, leaves us with 500 over 1,000 when we multiply that out. Go ahead and divide, and we are going to be left with 0.5 liters. And remember, in nursing with our zeros, we lead with zeros. We never follow with zeros. Okay? So we're going to say that this 500 milliliters is actually going to be 0.5 liters. So we've done all the work to get all of our units to be what we need for the formula. So let's go ahead and actually fill that in and solve this equation. So we know for molarity, it's going to be mole over liter. And at this point, it is the simple plug and chug. So going back to your notes, fill in your figure for moles, which would be 3.75 moles all over our liters. So we have 0.5 liters. Now we'll go ahead and use our trusty calculator. And as I've said before, just a simple $1 calculator from your local dollar store will do just fine. So we'll take 3.75, divide that by 0.5, and we are going to end up now with a molarity of 7.5. And do not forget your unit. So your molarity for that problem is 7.5 molarity. Okay? All right, so now let's take a look at one that requires us to kind of marry in some of our other concepts that we will have covered prior to this in another video. So here, I'm going to leave our little note. And this is going to be the problem we're going to look at this time. A solution is prepared by dissolving 9 grams of hydrogen bromide in water to a total volume of 800 milliliters. What is the molarity of this solution? So once again, remember we need all of our information to solve a molarity problem. We need moles and we need liters. So let's walk through what we have here for this particular problem. Okay, so take a moment to write that down. Pause the screen if necessary. All right. So now we're going to go and we're going to write some notes and solve this problem. Once again, I'm going to write at the top of our working paper here the fact of what our equation is for molarity. So remember we have big M equals moles over liters. Okay? So we know we need a mole, we need a liter of some kind. So let's take a look at our problem. It has given us 9 grams of excuse me, that should be a little r. So that's the lowercase r for it. So HBr. Okay? So we have hydrogen bromide. So those of you who know, I'm pretty particular. So HBr. Okay? 9 grams of HBr. We have to go back and remember our lesson now on what do we do when we have grams and we need moles. I believe we're going to need to do some type of gram to mole problem in order to receive the first portion of our equation. And how do we determine or how do we solve grams to moles? All right. So our first step for grams to moles is going to be find the molar mass. Okay. And then, of course, step 2, we're going to follow up with solve using dA. And for those of you who this might be your first video, dA is dimensional analysis. So let's go ahead and take a look at our periodic table and find the molar mass for HBr. Okay? So if we're doing that, we're going to say we have a hydrogen, we have a bromine, and we have just one of each. The periodic table that we are using, or I am using at this time, states that hydrogen is 1.01 grams per mole. And it also states that my bromine is 79.90 grams per mole. And since we only have one of each, all we need to do is add these figures. So we have 80.91 grams per mole when dealing with HBr. So now we can go in and solve our grams to mole problem using dimensional analysis and our ratio here for our molar mass. So since we are needing moles, that's what we're solving for. Let's change our pen color here. So you know we have moved on to now solving using dA. So we're searching for a number of moles. So that is what will be on the far left of our problem. All right. In dA, whatever unit is on the left is the first unit on that first line. So we know in looking at our problem, we weren't given any moles. So when we're doing our moles to grams or grams to moles, this is where our molar mass goes, right here in this first slot. So we have 1 mole, because we have 1 mole here. And then what is that 1 mole married to? 80.91 grams. Does everyone see that? Here we have 80.91 grams per mole. It's the same as saying for every 1 mole, I have 80.91 grams. Okay? Whatever unit is on the bottom, it goes directly across there. And now we can fill in some figure for gram because that's what we were given in the problem to begin with. Okay? It is all by itself. It was not attached to any other figures. So now we can go through crossing out like terms. And we're going to have 9 over 80.91. Go ahead and put that into your calculator and solve. And yes, you will end up with a long number. No, you will not round it at this time. So you're going to utilize all numbers that your calculator has supplied for that problem. Okay? So we have 0, because remember we lead in nursing, never follow. So 0.111234.7 moles of HBr. So we can go ahead and fill that in for our shopping list. All right. And if we look at it, our problem said that we had 800 milliliters. 800 milliliters. So we know that that, by definition, has to change. So once again, we'll do another dA conversion, solving for liters. So once again, let's come on down a little bit below where we worked on our molar mass and finding our moles. And let's go ahead and change our milliliters to liters. So once again, in true dA fashion, what we are solving for is on the far left, Whatever unit is here is the first unit on the line next to it. And we know for this problem we weren't given any liters, so it is necessary for us to use our conversion factor. So we are converting from milliliters to liters, so that is going to be 1 liter over 1,000 milliliters. Because as we go up and down that metric chart, we see that the ratio between liters and milliliters is 1,000. So there is a 1,000 to 1 ratio. Once again, we draw our next line. Whatever unit is on the bottom preceding goes right there on the next line. And in our problem, what ml were we given? We were given 800 mLs of uh, of a solution. So now we're going to go through crossing out our like terms. We're left just with liter, which is what we needed. So 1 times 800 is 800. 1,000 times 1 is 1,000. So if we divide, we are going to say that we have 0.8 liters. Okay? So we go up and we fill that in our shopping list, and we now have all portions to solve a molarity problem. We have some type of mole value. We have a liter here. So let's go ahead and plug those items in to our formula and find out the molarity for that solution. All right. So down here, we're going to say, once again, writing our formula. And you will hear me say, it will not matter how proficient you feel you are, always write that base formula. So now let's plug and chug. We know molarity is going to equal 0.112347 moles, all divided by 0.8 liters. Once again, all of that came from your shopping list. So this information for your moles, you actually worked that out by determining molar mass and converting grams to moles. You also did a DA conversion. And now you're going to complete this problem by using your calculator to plug and chug. And we're going to end up with 0.139043 molarity. And if I were to have you round that to the nearest hundredths place, remember we're going to look right here to this second spot and the place right ahead of it. Anything over 5, we will need to round up. So for this answer, we have 0.14 molarity for that final solution. All right. I hope you all have enjoyed and this made a few things a little more clear. Please, if necessary, go back, rewatch, and pause these videos to give yourself time to work them out on your own. And once again, happy studying, and I wish you all the best.